All right, USD students, Professor Pope, okay, Survey of Calc. So you should be very well aware of the square root function, okay? Y equals the square root of x. The function looks like this. If I said x equals 9, then hopefully you're able to tell me that the y value would be 3, because when you input 9, you get 3. So that's not calculus. That's the world before calculus. Before calculus, what we're doing is we're modeling position. When you get an x value, what you get out is your y value, your position. With calculus, you're going to be able to tell me how fast you are moving when x equals 9. Primarily, that's called the instantaneous rate of change at x equals 9. Now, the reason I'm going over this problem is it's one of the most fundamental aspects for calculus, and afterwards you're actually going to be able to do this in a much easier way. But for now, we're going to have to use a formula. I'm sure you're going to recall this formula from class when I write it down, but bottom line, the question is going to be, find the instantaneous rate of change at x equals 9. So, the formula that's being used is basically the limit definition for a derivative, okay, which is really just the instantaneous rate of change. Okay, so f of x plus h minus f of x over h as h goes to 0. So what we're going to do is we're going to write limit as h goes to 0, and then we're going to input x plus h into that function. Now obviously instead of y, I can make this f of x, right? So this is going to be root of x plus h minus root of x all over h. So now the next question is, how do we solve this limit? What we have to do is we have to rationalize the numerator. So what we do is we multiply by what's called the conjugate. Make sure you keep that in parentheses. So now, hopefully, we are able to understand that the top just becomes a simple difference of squares, which is x plus h minus x all over h parentheses root of x plus h plus root of x. Now, you might say, oh my God, why aren't you distributing? Don't. Just wait. Okay, so this is going to be limit as h goes to 0 of h over h parentheses root of x plus h minus root of x. So I'm going to go back up here, okay? So my h's cancel, right? And I'm left with the limit as h goes to 0 of 1 over root of x plus h minus root of x. Now, you might have said, well, why don't you just plug in 0 right now? Remember, if you plug in 0, you get division by 0. Division by 0 equals more work. Okay, more work comes in the form of either factoring, rationalizing, or simplifying. Here we're rationalizing. Okay, so here we go. We input 0. So limit as h goes to 0. Well, actually, okay. So how about we'll just input 0. We'll go from there. So that's going to be 1 over root of root of x minus, or plus, what am I doing? See, everybody messes up, including me. But when I mess up, I know that I messed up, therefore I'm able to change it, right? All right, so here we go. 1 over 2 root of x. So what does this mean? This right here is the derivative. What is this? So into this function, when I input an x value, what do I get out? I get a y value, right? The y value is 3. That's my position. That's where I'm at. Into this function, when I input an x value, what I'm going to get out is how fast I'm moving at that moment in time. So my x value is 9. So I'm going to write f prime of 9 equals 1 over 2 times root of 9. And I get 1 over, root of 9 is 3. 1 over 2 times 3 is 6. So what that means is that I am moving, if this is a position function, you'll have units, but let's say if it was in feet, whatever, you're moving 1/6 feet per second at that point. Okay? Now, let me add this as well. Every point on this graph, right, has what's known as a tangent line. The slope of the tangent line is the instantaneous rate of change. So the slope of that tangent line is 1/6. So if you guys want to know more information about calc and solve all your homework problems, as well as when you get into really, really hard derivatives and integrals, tune in. They'll be done.